Good morning, Smarties, and welcome to your math lesson for today, for Wednesday, April 22nd. We are going to be continuing our talk and discussion on three-dimensional 3D shapes, or solid figures like we learned as another name for them in our Brain Pop video yesterday. If you didn't check out yesterday's lesson, 14.6, make sure you check that out first because it was the introduction to 3D shapes. So that would be a good lesson to start on, because then I'm going to continue talking about the 3D shapes today, the non-defining and defining attributes that make them a 3D shape. But if you didn't check out yesterday's lesson, make sure you check that out, especially the Brain Pop video, and then we went on a scavenger hunt around the house to find three-dimensional shapes with certain objects around the house. So make sure you check that out before you do this lesson. Today, we are on 14.7, and we are going to be talking about defining and non-defining attributes, which we talked about when we did 2D shapes, for 3D shapes today. So we talked about an attribute is like a characteristic. We learned that straight sides, it has to be closed, and vertices, okay? We're defining attributes or sides, we're defining attributes for a 2D shape, okay? Size didn't matter, color didn't matter, the position of the shape didn't matter. The defining attributes were sides, vertices, and if it was closed. Today, we're going to be talking about the defining attributes for a 3D shape. What makes it a 3D shape? So, before we get started, I would like to see what we remember from yesterday before we get started with today's lesson. So, what 3D shape is this? You said cube? You are correct. This is a cube. Say cube. What 3D shape is this? Yes, it's a ball. But what is the geometric name for this 3D shape? If you said sphere, you are right. Sphere. Say sphere. About this. If you said cone, you are correct. Say cone. About how you take a cube and you stretch it and it makes a rectangular prism. If you said rectangular prism, you are correct. Say rectangular prism. And if you said cylinder, you are correct. This is a cylinder. Say cylinder. Okay, those were our shapes that we talked about yesterday that you went on a scavenger hunt for around your house. Also, what I want to talk about really quick is what we talked about yesterday, some vocabulary terms. Okay, we talked about face or flat surfaces. Okay, faces or flat surfaces. We talked about edges and vertices. Vertices was one that we used when we did 2D shapes, but face or flat surfaces and edges was new. So we're going to use our cube for example. I run my finger, okay, down the face or the flat surface of this cube, and it has several faces or flat surfaces. It actually has 1, 2, 3, 4, 5, 6. Okay, 6 faces or flat surfaces. Okay, the face of a cube is the shape of a square. Then we talked about edges. Okay, think about edge, like you're going to walk along like the balance beam. The edge of this cube, you don't want to fall off. Okay, the edges are like, they're your straight lines. So 1, 2, 3, 4 of this. 5, 6, 7, 8, 9, 10, 11. Whoops, I lost count. Here we go. Let's do the top. 1, 2, 3, 4. It's always easier to do the top than you do the bottom. 5, 6, 7, 8. I did the bottom face. Okay, 9, 10, 11, 12. I did the edges around. Okay, so it has 12 edges, and then our vertices, or our corners, okay, is where two edges meet. So this edge and this edge, they meet at the vertices. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 corners or 8 vertices. So those are a few vocabulary terms that I want to review from yesterday. Today, like I said, your I can statement is, I can choose the defining attributes of 3D shapes. So what are the defining attributes of a 3D shape? Before we do that, let's quickly do our solve and share to start us thinking about that. And then I have a video for you to watch. So, our solve and share for today says, are all three of these shapes considered cylinders? Why or why not? So take a look at these shapes, these three-dimensional shapes here. Think about what is a cylinder. And are all three of these cylinders? Why or why not? Think about what defines a cylinder. How many faces does it have to have? Does it have any edges or vertices? Think about what doesn't matter. We talked about that with 2D shapes. What doesn't matter when you're talking about defining a shape? Okay, we'll come back to this question. So think about that. I want to show you our video on our Envision's website for the lesson today. They may answer this in the video. I don't know. I haven't watched it yet. I'm going to watch it with you. If they do, great. Then you can check yourself. If they don't answer it, then we'll check it after to see what you came up with. The video might help you if you're struggling with this, or it might change your mind. So, here we go.
Are these all the same kind of 3D shape? Let's find out. How are these shapes alike?
Okay, so how are those shapes alike? What do you notice about them? Look at the face of this. Look at the face of this and look at the face of that green one. All of them have what shape is the face? If you said rectangle, you are correct. Okay, so they have rectangles as their faces, which makes it a rectangular prism. All right, so, and what else? Are they flat? Are they 2D or are they 3D? Okay, if you said that they are all three-dimensional shapes, you are also correct. Let's see what else they have to say.
They all have 6 faces, 8 vertices, and 12 edges. How are these shapes different? They are different colors and sizes. They are also in different positions. We define 3D shapes by the shape and number of faces or flat surfaces, and by the number of edges and vertices. How can you define a rectangular prism? It is a shape that has 6 faces, 8 vertices, and 12 edges. Are all of these shapes rectangular prisms?
Select your answer.
So, what we talked about in the beginning, they're the same ones from the very beginning, the first question. Okay, do all of them have 6 faces? 1, 2, and then the back 3, 4, top 5, 6. 1, 2, on the bottom 3, on the side 4, on the front 5, 6. 1, 2 on the back, on the bottom 3, and on the top 4, and then on the back 5, 6. So they all have 6 faces. Okay, the 8 vertices are the corners, the 4 on the top and the 4 on the bottom, and then your edges. So are all of these shapes rectangular prisms? If you said yes, let's see if you're correct. There you go.
Yes, they all have the traits needed for rectangular prisms. Why are these shapes not the same kind of shape? One shape has no flat surfaces, some have no vertices, and some have no edges. The flat surfaces on one shape are rectangles, and on another are circles. Color does not define shapes. Just because shapes are the same size or color does not mean they are the same. These shapes are all green, but there is a rectangular prism, a sphere, and a cylinder. Color does not define shapes. What is each of these shapes? How do you know?
So what is each of these shapes? How do you know? Okay, what is this? Rectangular prism, rectangular prism, rectangular prism, because we know by the faces, the edges, and the vertices, the defining attributes.
Each of these shapes is a rectangular prism. All of the shapes have 6 faces, 8 vertices, and 12 edges. Are all of the rectangular prisms facing the same way? No, they are not all facing the same way. Are all of the rectangular prisms the same size? No, they are not all the same size. Does size or position determine if the shapes are rectangular prisms?
What do you think? Does size or position determine if the shapes are rectangular prisms? We talked about that in 2D shapes. Very similar question. Does it matter if they are small rectangular prisms or big rectangular prisms, or if they're going a certain way? Okay, so we're just think about this for a second. Are these all the same shape or different shape? If you had said same, you are correct. If are these same or different? Even though they are going different ways and different sizes, does color matter? No, they are the same shape. They're all cylinders. What about these? Oh my, you have a rectangular prism, a sphere, and a cylinder. Are those the same? No, those are different. And what about all of these? You have spheres. Yes, they're different colors. Yes, they're different sizes, but that does not matter. They are all spheres.
No. Color, size, and direction don't define a shape. Some things about these shapes are different, but they are all rectangular prisms.
All right. So, back to our solve and share. Okay, that might have helped you. Are these the same shape? If you said yes, they are they all cylinders? And you said yes, then you are correct. Okay, they both have, all of them have 2 flat surfaces, or 2 faces, 0 vertices and 0 edges. Okay, but they are all cylinders. Yes, this is a tall, long red one. This is kind of a shorter, on its side green one, and this is like almost like a penny size as far as the how thick it is. Okay, it's pretty flat, a flat cylinder, maybe more like, I guess, a can of tuna. okay? But it's still a cylinder. So, yes, these are cylinders because of, like I said, they have 2 faces, 0 vertices, and 0 edges. Color, size, position does not matter. Those are non-defining attributes. Okay, I have some real life ones. So here, look at this cylinder. It's kind of perfect that they talk about cylinders. This is a cylinder. Face 1, face 2. No vertices, because that's where the edges meet, and no edges. Cylinder. Face 1, face 2. Okay. It's just this guy stretched out. All right, both of these are cylinders. Okay, size, position, even if this one was on a side, okay, does not matter. So, that is your lesson for today, talking about non-defining and defining attributes. Let's do this kind of for your activity. It's harder to do these when you don't have 3D shapes. Okay, but all cubes. We talked about cubes. Do all cubes have 12 edges? Do all cubes have 8 vertices? Cannot roll. Can a cube roll? And are blue. Which ones are correct? Okay, well, we know that this one's not correct. All cubes don't have to be blue. Color doesn't matter. Can cubes roll? They cannot roll. So that one is true. It's not a sphere. It cannot roll. Okay? What about 8 vertices? Here's our cube. Count the corners on the bottom. 4. And on the top, 4. What's 4 plus 4? 8. They do have 8 vertices and 12 edges. Okay, 4 on the bottom, 4 on the top. That's 8. 9, 10, 2 on the side, 11, 12. They do have 12 edges. Okay, so the only thing that's not true about all cubes is they do not all have to be blue. Again, a non-defining attribute. See if you can do the cylinder on your own. It says, the directions say, circle the words that are true for each shape. We did the cube together. See if you can do the cylinder on your own. It says, all cylinders have 2 flat surfaces. Cannot roll, are red, and can roll. Which ones of these are true? Okay, which statements are true? Here's a cylinder, and then there's one right there for you to look at as well. See if you can do that one on your own. That is your math lesson for today. I will be back in a little bit with your science project on the phases of the moon. Nice job today, Smarties. Bye for now.